Containers gradually take over IT infrastructure. Well, their increasing popularity actually forces us to think about how to protect data in this sort of stateless world. So we think about containers like a stateless infrastructure, but still you have to keep some persistent data somewhere in this environment. So today's topic is best practices for backup and recovery for Kubernetes environments. My name is Marcin Kubacki. I am Chief Software Architect at Storware. I'm responsible for the backup and recovery solutions in Storware. And let's briefly think today how we are going to even consider backup for the Kubernetes environment. So first of all, we have to think about the actual costs. Why do we need to protect it? So infrastructure and hardware failures in many cases are one of the core causes that you need to consider. Then you have the outages, like the complete data center loss, human errors. I believe that this one is most commonly referred and most commonly noticeable problem that you need to address. Typical data loss, data corruption, maybe some ransomware attacking your volumes, and obviously some other natural disasters. Not all containers are stateless, so you still have to remember that there is some place where you need to keep your data and you need to keep track of the changes. So it's not always about bringing back automatically the application itself, but in many cases you need to think how to bring back the original data as well. So persistent volumes is one of the very first things to consider whenever we are protecting this environment. So we treat them sort of like virtual machine disks in the regular virtualization world. Then you have the deployments or deployment configurations, so metadata, similar to regular virtual machine, that you also need to bring back to the original state. Some of these can be protected on the Git level, let's say infrastructure as a code approach. Some of them are not. And finally, there is a central place to store all of this metadata, so etcd, that also needs to be protected. So vProtect tries to address several layers of data protection as far as the Kubernetes is concerned. So we cover multiple different virtualization platforms, and not only it's containers world as well, it's also the cloud instances like the Amazon that you can see here. So today we are focusing on the Kubernetes itself. So major features are all about the agentless backup and recovery process for your infrastructure. So instead of installing agents in multiple places and managing them, we try to protect on the, let's say, VM level or container sort of deployment level, and in agentless your infrastructure, both for full and incremental backups. So that depends on the storage, but we'll get to that later. So then you have several aspects, maybe not specifically for the Kubernetes, but snapshot management. You have to think about it as well. If you have a storage capable of doing snapshots, you could also consider vProtect for doing that. Application backup. So because it's a sort of generic mechanism, it would address multiple different problems when we are facing backup and recovery for Kubernetes applications residing in this environment. And you also need to think about vProtect like the either standalone solution or a missing puzzle that would be able to use your existing legacy backup, enterprise-grade backup system, and extend its capability to protect Kubernetes environment as well. As far as the backends are concerned, you can also use plain file system. You can use any storage that you already have, some object storage. If it's only supports S3, it would also mean that you can use on-prem S3 object storage solutions. And as I mentioned, enterprise backup vendors like the IBM, Dell, and Veritas. Wherever you have more complex deployments and you would like to have backup to be a part of the bigger orchestration engine, you can also use APIs offered by vProtect to smoothly integrate it with your current workflow. So the overall architecture looks like this. So vProtect is a puzzle that is able to protect multiple different multiple sources, in this case multiple types of sources. Especially we are focused on the container world today, but not only let's say you have to think about the cloud instances, virtual machines, and in general the applications. Now these applications, keep in mind that it is a very generic way of saying that we are focusing only on the application residing on Kubernetes. It also means hypervisor layer, so in Kubernetes terms like the etcd, for instance, and other applications that even not reside in the same environment. On the right side, obviously, you have the different targets that I already mentioned. Especially notice that video here, which comes also is automatically configured by vProtect, allows you to have to enable the duplication on your existing file systems, existing storage that you have. Behind the scenes, there are two main components in vProtect. One is server. This is the metadata place. This is the place where you can configure, manage over all of the jobs, and nodes that are data movers. So we can have multiple data movers managed by the single server. And from the Kubernetes perspective, you will see that in a moment. You can place these nodes depending on the actual use case outside of the Kubernetes environment, but still you have the option to have multiple nodes to scale out if you need. In details, there are actually several workflows behind the scenes. So there are, depending on the source, there are 2 or 3 core workflows for the data protection. So one is obviously virtualization, container, cloud instance layer. This focuses on the persistent volumes and overall metadata of the Kubernetes. The other one is the application backup integration. This allows you to grab the configuration of the Kubernetes itself or whatever other container orchestrator you have, and any other applications, even if they reside outside of the Kubernetes. So you are able to integrate with your existing scripts or native commands virtually any additional protection and cover these additional applications with this integration. All of them obviously end up on the staging space and later are being moved by the vProtect node to specific backup provider. vProtect node uses the same set of APIs as the command line interface or web interface, so you have exactly the same capability later to integrate vProtect with your third-party system. So some orchestration, some self-service portal, some monitoring system. And vProtect server hosts these APIs and as well the web interface that I have mentioned. So vProtect server is responsible for the keeping all of this metadata. Database that is mentioned in here is small one, so it's not really something complex later to bring back if you lose completely your vProtect installation. For Kubernetes, we focus around the pods and actually on deployment. So whenever you have to protect some file-based persistent volumes, we are able to execute helper side pod and grab files on the file level from your from your deployment. Optionally, you can pause deployment during this operation if you really would like to have consistent backup. But without snapshot capability, this would mean that you have temporarily paused your applications, which in many cases it's not suitable. The other thing is that whenever you have the Ceph behind the scenes, this allows you few additional scenarios. So one is especially when you have Ceph RBD connected directly to the persistent volumes, and we are able to create snapshot and export with the regular RBD NBD or RBD export directly from your Ceph. This also allows us to use storage providers, so focus on the Ceph regardless of what's the purpose and why it is used in there. So we are able to scan for RBD volumes and snapshot them and export directly to vProtect. So you have, let's say, two scenarios. One is the volume protection in context of the deployment, and the other is to have standalone Ceph data protection if you would like to protect just data without the actual deployment metadata. Obviously, the restore process is exactly the opposite. So we recreate the persistent volumes, pump data in, and recreate deployment based on these volumes if needed. Probably you're going to have multiple deployments. Each of them have different labels, and maybe you have some specific naming convention for your deployments. So either by the regular expressions and name convention, or using the labels, and we call them tags. You can automatically create set of rules to automatically assign virtual machines, or in this case deployments, to specific policy. So you don't have to manually monitor and add deployments one by one. It can happen automatically for you. For the deployments, I already mentioned, you can optionally pause deployment. So this is one of the approaches, and the other is that we optionally allow user to execute custom scripts before export takes place and after export completes. Maybe you would like to quiet some application behind the scenes so that it is directly quiet on the application level, not on the storage level in this case. And finally, you would like also to initiate multiple restore process with recovery plans. So this allows you to pre-configure restore parameters and then execute batch restores directly on multiple VMs without to click, deployments without to click one by one and pass all of these parameters again and again. You also are able to schedule recovery plans so that it allows you to periodically restore and test if the deployment is successfully up and running after it is being restored from your most recent backup. I already mentioned application backup earlier, so there are two main definitions that we have to focus right now on. One is execution configuration. It basically describes how you would like to execute the backup process itself. So what you need to protect, what files, what command, or maybe some script, or maybe some command remotely on your container, or executed from the node, you would like to invoke during each backup process. Now, this command can be, this command execution configuration is later being shared by multiple applications. So you can imagine that you have MySQL database, and you have prepared a single script. It's already, actually, there is also a template built in vProtect ready for you, and you would like to reuse it multiple times. So the target can virtually be anything, because either your command, like MySQL dump, can be invoked against any remote system, and the same applies also to SSH. It can also be a physical box running, and we can execute this command remotely over SSH, even on the physical boxes. It doesn't really matter at this point. The main idea here is to protect several different layers with the same mechanism. So we were able to protect etcd database, so your complete metadata repository. You can backup applications inside the deployments. Maybe you have specific configurations in there. Maybe you would like to protect databases inside your containers with the native mechanisms, because snapshot may not be suitable for such backups, or just a plain set of files that is maybe on some share, maybe in some other location. Notice as well that with the with the most recent version, you also have file system storage provider available in vProtect as a third type of source that you could also utilize to protect specific storage repositories, storage shares, some network shares directly from your vProtect, still in an agentless way. Now, I have mentioned about this execution configuration. There are predefined templates, but just to give you an example how you could create your own configuration, you just need to provide obviously some name, if it's going to be executed remotely or as a command on the node, what are the command arguments, do you want to export data, because that may not always be that obvious. You may just want vProtect to act as a scheduler for some external backup tools like the Oracle Airman, for instance. And if you are exporting this data, if it's a file, or you expect the standard output to be used as the target for your backup in this case. Now, execution configurations are standardized, so you need to provide what do you expect, what your script or your command expects as a set of parameters. So you describe them in a way so that your other administrators will understand that they need to provide, let's say, a database name as the parameter, and later whenever you create an application instance from the execution configuration, it will automatically prepare a set of environmental variables that are ready to be filled for this particular application instance. Okay, now let's go with the live demo. I'm logging to my Kubernetes installation right now. I have set of deployments. One of them is going to be my MySQL database to be protected, so I have MySQL once deployment here. It has one replica set which consists currently of one pod, and this pod has persistent volume claim. So this is a small volume that we are going to back up right now. Now, in the vProtect user interface, I'm logging in here as the administrator. As you can see, I have 3 different sources to protect. So we can perceive Kubernetes environment in a different way. So we can think about virtual environments. So it can be, in this case, our deployments. It can be applications running on these containers inside Kubernetes environment, and I can have storage volume. So let's say that is my Ceph RBD, for instance, that I would like to protect separately and from just directly from the Ceph layer. In general, dashboard also provides me some information about the recently failed backups, let's say, some success rate, activity that I have, reporting capabilities, and configuration wizard if I would like to quickly set up vProtect. Here I also have video with the duplication ratio, so you can also consider vProtect as the standalone solution with the deduplication capability to significantly reduce the storage requirements that you have to that you would otherwise need to use to protect your data. Now, in my environment, I have 2 nodes. One of them is the one that I'm going to use. I can have multiple node configurations, so that I don't have to configure each node separately, but rather group the settings and assign them to multiple nodes. And in my virtual environment, from the vProtect perspective, Kubernetes is going to be a hypervisor manager. So Kubernetes nodes are going to appear as the hypervisors. And notice that we try to have the hypervisor, let's say agnostic style in this case. So we would like to have consistent and the same approach for all of the platforms that we support, so that the overall user experience stays the same regardless of what type of platforms are you protecting. In this case, you can have a mixture of let's say OpenStack, Nutanix, Ovirt, and container world with the Kubernetes itself. So whenever you add Kubernetes as the hypervisor manager here, you later are able to initiate inventory synchronization and using this particular node. And once you have initiated, you're going to have additional Kubernetes nodes here available and visible on the list. Now, in the instances view, we have both the deployments and regular virtual machines. So in this case, we are focused on the deployments level. You can see that I would like now just to focus on the, let's say, Kubernetes deployments, and MySQL once here is visible. It has one disk. It means actually that it has one persistent volume, and there are some backup history already available. I can filter out based on the specific time range. I can see backup sizes, backup times, especially important if you have maybe some bottlenecks at the end. You would like to see which part of the backup process usually takes the longest. The same applies to the restore duration. Notice as well that we scan for the tags, so it labels in the Kubernetes world, so this helps you later to create rules for automatic policy assignment. Now I will initiate backup process. I would like to initiate full backup for this VM. Incremental would be also supported, but only with this FRBD behind the scenes. In the meantime, in the settings, you can see that there are also options to execute pre, post, export, custom commands directly on your application. At the bottom, I have export task already in my queue. It's running, and every backup is two-stage process. So once the export completes, another store task is going to appear, and it is going to push backup to your external maybe backup destination that you have configured. In some cases, well, in most cases actually, if you have a standalone vProtect installation, it is quite common to have staging space shared together with the backup destination. In that approach, vProtect is able to quickly move data to the backup destination without the need to copy data twice or send it somewhere else. Notice that it has just finished, so I should have additional backup here on my list. As you can see, an additional chart has appeared, and in the backup history I have a third backup already completed. Now, as far as the policies are concerned, policies have multiple schedules, so you create a policy and assign both virtual environments. You specify the rules of auto assignment of the VMs or deployments in this case, and you specify which schedules are going to be used for this particular policy and where the data is going to be stored. Each schedules can be defined separately here, and you can have two types of schedules. One is scheduled for a specific time, and you can also have interval-based backups as well. Now, snapshot SLAs are not supported for the Kubernetes environment yet, but still you could use snapshot management capabilities for Ceph RBD volumes separately. Recovery plans, this is the, let's say, sort of a policy that, but actually working in the other way. So we would like to have periodic or on-demand restores of multiple virtual machines. So I can create this type of policy, give it a name like the Kubernetes prod, and then I need to create rules, so I can specify individual rules for set of deployments that I have. Maybe I would like to have production deployments, let's say, be as a part of a single rule. So let's say prod 1. And I can specify my deployments like MySQL ones. Optionally, I can provide schedules if I would like to have periodic restores. And restore parameters, they always need to be consistent. So whenever you specify a rule for the actual recovery plan, well, each rule needs to have to group virtual machines or deployments of the same type, so that restore parameters can be used for all of them. So as you can see, you can restore to the specific project. You can optionally add some prefix to the name and delete previous environments if they are already in place. For the environments that use row-based backups, you are also able to use file-level recovery. This allows you to mount such backup and recover individual files directly from the web interface or via command line or directly on the node. So you can copy out the data directly from your deployment. Now the application backup part is the one that I have already previously mentioned. Notice that I have execution configurations on the left here. So this is some of them are predefined. Notice that you cannot remove them, and one of them is Kubernetes /OpenShift etcd database. So this allows us to create later the configuration that is specific for my environment. So I have instances of my applications. I defined such application here, and I need to specify which execution configuration I'm going to use. This one requires SSH access to your Kubernetes environment, so that we can execute the etc database dump commands, and extends data protection from the regular deployment-centric level also to the metadata of your Kubernetes, so that you could also recover your Kubernetes cluster if needed. The same applies, the same what applied to the regular deployments. You also have backup SLAs. You create policies and schedules and assign applications to these policies in this tab. And finally, storages. So it is more and more common to deploy Kubernetes or OpenShift environments with the Ceph underneath. So persistent volumes are automatically provided by the Ceph instance behind the scenes. So you can also treat your Ceph instances, Ceph cluster, as a separate entity, regardless of what is being used for. If it's for, let's say, for big data, for OpenStack, or for OpenShift, or Kubernetes. So in this case, you also have the infrastructure tab, and you have a storage provider where you provide keys and configuration for your Ceph RBD instance. You later initiate inventory synchronization, and your instances in this case are the Ceph RBD volumes. The process stays the same, so you will later assign policies and schedules in exactly the same way as you do with the virtual machine. So the overall user experience stays the same, and we have the same logic applied also to the storages. Notice that I have 3 different layers of data protection for the Kubernetes in this case. So I can focus on my deployments, I can focus on the applications residing in there, and in some cases, if I have Ceph RBD, also on the storage behind the scenes. So the same applies, the same logic also applies to the reporting, so the successful rate, and also to the backup size reporting for chargeback, for instance. If you have multiple projects, you would like later to have some ability to keep track which project generates most of your costs in your backup infrastructure as well. So that's everything for today. So thank you for watching, and stay tuned for other videos.